Hello, everyone. My mind map is based on Descriptive Analysis in Education, a research guide for educations by Susanna Loeb et al. This paper is divided into 4 sections. What is descriptive analysis and why is it important? How to approach descriptive analysis, how to conduct descriptive analysis, and how to communicate descriptive analysis. First, what is descriptive analysis and why is it important? Descriptive analysis is analysis of the world or a phenomenon of interest by identifying trends and patterns in data through investigative and/or statistical analysis to answer questions about who, what, when, where, and to what extent. This data might be pre-existing or generated through causal research. Regardless of the source, the data alone isn't meaningful. It's only when the trends and patterns emerge that are relevant to reality that it becomes meaningful. Descriptive analysis achieves that. It provides context about capacities, needs, methods, practices, policies, populations, and settings in a manner that is relevant to specific research or a specific policy question. This improves our knowledge of the phenomenon of interest and allows us to do things like create policy, inform new practice, and even generate new research. So how does one approach descriptive analysis? First, a researcher must identify a phenomenon of interest. Good researchers will then fully consider the phenomenon to determine each of the aspects or concepts that it might have. Next, the researcher will determine which concepts of the phenomenon are the most important, which are not. This helps to inform the researcher about what types of data collection to use. Example, a researcher who's trying to describe variation in classroom engagement may consider a variety of interrelated factors like student motivation, teacher instruction, number and nature of peers, etc. Next, the researcher will determine which measures best represent these important concepts. Using the classroom engagement example again, if number and nature of peers was identified as a critical concept, then the researcher could use data such as attendance records, report cards, and interviews, etc. Ultimately, the goal of this step is to distill the important concepts of the phenomena into data for analysis. The next step involves determining whether or not there are observable patterns in the data. Researchers will often use statistical analysis to scrutinize data and identify trends. Provided the measures used to generate the data were both reliable and valid, which we will talk about shortly, the data will be meaningful. Thus, any trends or patterns identified will also be meaningful. The next responsibility of the researcher will be to communicate those patterns in a way that is meaningful and understandable. Good researchers will reduce the data and trends into a format that's best suited to their audience. The audience can be other researchers, educators, and policymakers. Efficient data reduction into data representation should not compromise the quality of the data, and the research must be reported transparently with details available to those interested. The last step is to rethink and repeat. Descriptive analysis is an iterative process, with each step building on the last. Sometimes reconsideration is necessary. Perhaps the researcher will determine that a different concept or different data collection method will be preferable. As the researcher's understanding of the phenomenon increases, their choices will be more informed, allowing for the advancement in the study or possibly the start of a new study. Okay, now we're moving on to the third branch, conducting descriptive analysis. An important step in conducting descriptive analysis is determining a sample that is representative of the population of interest. Researchers may be limited in their choice of sample by pre-existing data, or because they are collecting their own data and have limited time, funding, or access to the respondents and proper collection systems. Thus, it is important that a researcher transparently explains the strength and limitations of their sample as it relates to the study in hand. A clearly observed trend or relationship observed in a sample, referred to as internal validity, may or may not be reflective of the population of interest, referred to as external validity, depending on how well the sample was chosen. Equally as important is which measures are used to describe the concepts of interest. Measures used to create data must be valid and reliable. Validity refers to capturing the concept of interest and representing it appropriately. Example, one could consider using the number of times a teacher reports meeting with a parent as a measure of parent engagement with their child's school. If those meetings were initiated by the parents, this could be valid data. If, however, the meetings were initiated by the teacher in response to the child misbehaving in school, this would not be a valid representation. Reliability, on the other hand, refers to how precisely and accurately it represents the concept of interest. Example, if we're interested in a student's vocabulary or student vocabulary, asking each student all possible words is not practical. On the other hand, asking each student only 2 words is more feasible, but not at all accurate. Some students will know many words, but not the specific one chosen, while others will know very few, but just happen to know the word selected. Therefore, it is ultimately the job of the researcher to choose the most appropriate measures. They should utilize their intuition, awareness of prior research, and examine what data is available and what data can be collected. Unfortunately, a common occurrence in research is the absence of ideal data, forcing researchers to rely on something called proxy data. Proxy data is data that relates to but is not a direct measure of a construct. Because of this, proxy data is by definition imperfect, but sometimes necessary and commonly used when they are a reasonable substitute or approximation. If a researcher chooses to use proxy data, it is important that they, 1, describe why the proxy is relevant for answering the research question, and 2, describe the imperfections of their measuring of the underlying concept. Using the previous example of measuring parental involvement at school, the researcher may only have access to proxy data such as the number of times the parent entered the school. As we know, this data might not be a valid proxy because it may also include instances where the parent entered the school to deal with their child's misbehavior. Instead, limiting measures to the number of times the parent and volunteers at schools attended school-wide meetings or participated in PTA events is likely to be far more valid, but still imperfect. Okay, so now we have the data. What's next? Good descriptive analysis relies primarily on low inference, low assumption methods that use no or minimal statistical adjustments. This means that measures of central tendency like mean, median, and mode, measures of variation such as range and standard deviation, and basic frequency are especially useful statistical tools. In fact, using both central tendency and measures of variation are often the best strategy in descriptive analysis. Example, race A may on average have a higher score than race B on a particular assessment. However, this masks the fact that many race B students score higher than the race A students. Therefore, central tendency alone is only telling part of the story, and by adding measures of variation, we could flesh out the story more completely. Regardless of the statistical analysis used, statistical adjustments may be appropriate and helpful when a researcher is trying to ensure that measures are comparable. Example, test scores from one group were collected from ages 8 to 10, while scores from another group collected at ages 9 to 11. A statistical model could be used to adjust the average scores in each group to account for the differences in ages between samples. Be aware that statistical adjustments must be used with caution, as they can mask underlying relationships in data. If, for example, a researcher is interested in racial or ethnic differences across groups, but includes controls for income and residential concepts, statistical adjustments might mask actual differences in the group that reflect economic or social segregation. In addition to the statistical techniques mentioned, new analytical methods are emerging to identify and explore more recently observed grouping phenomena such as networks and clustering. Clusters are groups of units, which could be students, teachers, schools, etc., that have similar traits but do not interact with one another. Members of a cluster would share multiple characteristics but would be distinct from other clusters. Networks, by comparison, could represent a group of students organizing themselves into certain course-taking patterns. In the case of networks, there is interactions between the members of the network. Thus, network analysis and cluster analysis are 2 common methods for studying these phenomena. Network analysis describes the systems of links between or among the people or other subjects of the study, whereas cluster analysis describes sets of actors, as in people or courses, etc., with the same characteristics. Given the use of statistical testing, both fishing and mining should be mentioned. Fishing refers to analysis in which the primary motivation is to look for any and all patterns in a dataset without the boundaries of a preconceived hypothesis. Researchers may search or fish for statistically significant relationships and rely too heavily on statistical significance to signal an important result. Statistical significance is only a measure of how unlikely a relationship is to exist in the population of interest given the size of the sample. Mining, however, can be a very productive avenue for description if it is approached carefully. Data mining involves the use of every observation and feature for the purpose of describing what is actually relevant in reality. Data mining can lead to the identification of new patterns in data that were not previously recognized, thus providing foundations for subsequent causal analysis. All right, on to branch number 4, communicating descriptive analysis. No matter how significant the findings of a research study are, they only offer value if they can be understood by others. Thus, it's important that a researcher is able to reduce the body of data to a format that is useful to the audience of the study. This is often an iterative process, and different approaches to visualization and presentation should be investigated. Begin by deciding what the story is, the message, and to whom it will be told, the audience. Only then can the researcher make sound decisions about the most effective way to communicate the story, customization. Data visualization is a useful tool for communicating research finding, as data is generally easier to process and understand when it is represented in a visual way, such as a graph. This makes it easier for the audience to identify and understand patterns in data. When considering visualization, one should focus on three key features: function, familiarity, and simplicity. Function. Graphics should accurately reflect the data and appropriately illustrate the story of your findings. This often involves emphasizing the most important patterns in the data for answering the research question. Familiarity refers to the fact that people tend to process information more quickly when it's presented in a familiar way. Example, time trends are typically presented as line graphs with time on the x-axis and the variable of interest on the y-axis. If there is a standard way of presenting data, a researcher should have a strong reason to deviate from the norm. Simplicity refers to the fact that good communication should be simple. While a researcher may want to add visual interest, cosmetics should be secondary to effective communication. The use of pictures, colors, and other imagery only serve as distraction. Data visualization should always preserve the integrity of the message and not detract from accuracy or integrity. Ultimately, researchers have many options when approaching data visualization. The same statistical fact can be expressed in multiple ways, such as a table, a line graph, a scatter graph, etc. But keep it simple. For most audiences, tables and graphs are the easiest visualizations to interpret. If using a table, consider they are the most effective when displaying only a few data points, presenting secondary findings, or reporting standard errors, confidence intervals, and significance levels. Be thoughtful about table titles. A good title will convey meaningful information to your audience. Lastly, include detailed description in the caption to ensure the table can stand alone. As a simple rule of thumb, any information that can be accurately presented in graphic form should be presented in graphic form. Graphs are more easily understood than tables. Area graphs, bar and column charts, scatter plots, and line graphs can all be suitable choices if they are chosen based on meaningful criteria such as data type, message, and the audience need. Don't just choose what's easiest to create in a spreadsheet. Line graphs are appropriate for continuous data and are an effective way to present slopes. Bar graphs are appropriate for discrete data and can be used to easily distinguish magnitude and proportion. Maps, like heat maps, are useful for describing geographic variation. Ultimately, unnecessarily complex presentation is an obstacle to effective communication. For most audiences, graphs and tables are more appropriate than 3D imagery or other complex presentations. It is essential that graphics present just enough information as necessary to fully meet the needs of the audience. So that wraps up the paper. Don't forget to review the discussion questions provided, and I hope you enjoyed it. Thank you very much.